everybody, my name is Kate Berry from the University of Texas at Austin, and welcome to this Math Spiral video on precise math language. When we're thinking about precise math language, I really want to first direct your attention to this instructional platform. And when we're thinking about our best ways to support students with math difficulty or math disabilities, we always want to refer back to our instructional platform. So as educators, we need to be integrating 5 main components into our math instruction. First, explicit instruction. Second, vocabulary, and this is where our precise math language piece comes in. Third, multiple representations. Fourth, fluency, and lastly, my favorite, problem solving. But let's now take a closer look at what we mean by vocabulary or precise language. How can we integrate precise math language into our class? Let's take a look. When we're thinking about students, and especially in Texas here, we're thinking about how students need to understand the language of math. Students in classrooms are required to listen to you talk about math. They're required to speak about math, read and write about math on your tests, on standardized assessments. So it's really important that students have an opportunity to understand the language of math beyond just the abstract numbers and symbols. There are 2 key components when we're thinking about precise math language that I want you to think about when you're thinking about your instructional platform and how you can support your learners. So the first thing that we want to make sure that we're doing is using formal math language in our classroom. And the second thing that we want to make sure that we're doing is using math terms precisely. So I'm going to talk about both of these things in more detail on the coming slides. So let's take a look at our first component. Our first component that we want to think about when we're thinking about precise math language is using formal math language. And you might be thinking, well, Kate, what do you mean when you say formal math language? What I'm really talking about is making sure that the language that you're using in your classroom with your students directly aligns with the language that students are seeing in workbooks, on tests, and on those standardized assessments. So if you're talking about fractions, instead of saying bottom number, we want to be saying denominator. If you're talking about multiplication, instead of saying what is the answer, you need to be saying what is the product. So let's look at a couple examples of how you can turn informal math language into formal math language. So let's look at our first speech bubble over here. It says, what number is in the tens place? Instead of number, we want to be saying what digit is in the tens place. This is how we're moving from informal to formal math language. Here, when we look at our second example, this says you need to carry the 1. We don't want to say carry the 1. We want to say let's regroup, trade, or exchange. These are formal math language terms. Lastly, it says it's time to reduce the fraction. If we say reduce the fraction, that implies that our fraction is changing. To transfer to formal math language, we want to say it's time to simplify the fraction. And as educators, of course, sometimes you're going to accidentally say informal math terms in your classroom, but we just want you to be aware in your head as you're teaching, oh, wow, yeah, instead of saying answer, I need to say product or quotient or sum, okay? We want to just make sure that you're being cognizant and aware of the many different ways you can change informal to formal math language. And one way I like to do that is through this little activity here. You can think about your math standards and think about instead of this, so instead of this informal term, say that, which is this formal term. So instead of corner, you might say angle. Instead of square, you might say cube. So really it's just a fun opportunity for you to jot down some ideas and thinking about, again, the standards. So geometry, measurement, we might be thinking about number sense and operation. Instead of saying distance around a figure, you might say perimeter. So really just using this little tool or this worksheet as a guide to help you transfer informal terms to formal math language. In addition to using formal math language, we also want to use math terms precisely. A lot of times there are words that seem like they mean the same thing, or they're clustered with words that mean similar things. We want to make sure that we're explicitly teaching these terms to students. We can explicitly teach these terms to students using our explicit instruction model, and as well making sure that we're integrating pictorial and concrete representations to help students differentiate between these terms. If you're thinking, well, what terms are you talking about, Kate? We might think about words like angle, base, edge, face, side, vertex. These all seem very connected. They are very connected, but they have very different definitions. Or for example, factor and multiple. Can students differentiate between those terms? So really thinking about opportunities that you have in your classroom to help students understand math terms precisely through your explicit teaching of the precise vocabulary. Here's some other examples of terms that we would need to teach our students. Again, I mentioned factor and multiple. Here we have fractions. Do your students understand the difference between proper fractions, mixed numbers, ratios, unit fractions, etc.? When we look at angles, that's another example. Can your students differentiate between corresponding angles, straight angles, adjacent angles? So really thinking about those clusters of vocabulary words within your different strands that you need to explicitly teach to make sure that students are understanding the language of math. So again, when we're thinking about our explicit instruction and our vocabulary, our multiple representations, our fluency, and our problem solving in our instructional platform, we really want to think about that vocabulary and that specific precise math language. And two components that we talked about in this video that I want you to think about when you're thinking about vocabulary are, number one, using that formal math language. So instead of saying this term, say that term. And secondly, I want you to think about using math terms precisely. So what are those clusters of words that we might need to explicitly teach to students? And again, we're going to inform our teaching through our educational instructional platform. And again, we're thinking about this vocabulary piece when we're thinking about our precise math language. Thank you so much for tuning into this Spiral video on precise math language. We look forward to seeing you soon.